And very good afternoon to all of you. And for those who may not be in this part of the world, a good day to you. Welcome to this session. Um, Let me first tell you a bit about APARA. APARA is the Asia Pacific Assistive Robotics Association, and we pride ourselves in helping organizations look at how best we could leverage AI technology as well as robotic technology to augment human capability and potential. Now, there's a lot of talk about AI and there's a lot of talk about robotics. And in the most prevailing industries such as manufacturing and perhaps even finance, but not much to talk about in terms of AI in the construction industry. I believe there's huge potential to look at what AI and robotics can do in the construction industry. Hence, together with the organizer of BTA Asia, we thought we'd like to spend a little bit of time to share with you, give you a quick review around what is happening in this space. Today, we've got three speakers, three charming gentlemen who's going to share with you around this technology. The first speaker will talk around AI and how ready can your organization be in adopting AI technology and what can be done to support you in going through the journey to deploy AI solutions. Then we've got two gentlemen who are going to share with you something very novel. And in fact, the technology has picked up so much in this year itself around 3D printed buildings. Now that's something that's going to be very exciting. We'll show some videos and you can then ask questions if you need to in the Q&A session. So first, please allow me to introduce the first speaker. And he's none other than Mr. Lim Tian-Po. Mr. Lim is actually the assistant head for AI standards at AI Singapore. Now, AI Singapore is an agency in Singapore that looks at helping companies in both the commercial space as well as in research to explore the use of AI technology and help build skills as well as deploy the most viable product necessary for the commercial enterprise to adopt. Today, Mr. Lim will share with you a very key topic, and that is accelerating AI adoption with an AI Readiness Index. So, Tian-Po, over to you.
Okay, thanks, Olivia. So, hi, everybody. Good afternoon. So, my name is Tian-Po. I'm glad to be here to share with you an initiative by AI Singapore. So, AI Singapore, we are a national program office. So, our mission here is really to help companies accelerate their AI adoptions. Right? So, I'll be bringing you through this initiative that we have created that is called AI Readiness Index and how that might help your companies to accelerate your AI adoption. So AI Singapore, we are in a very privileged position because as a national program office, we have the opportunity to speak to a lot of companies in various sectors, be it healthcare, logistics, and across companies of different sizes, be it startup, SMEs, or big AMCs. Right? So what we realized is that a lot of times, right, the organizations misunderstood the factors needed for successful AI adoptions. So for instance, right, a lot of organizations assume that AI is only about algorithms, right? But in reality, AI requires the talents, good use cases, quality data, and sufficient IT infrastructure in order for the organization to adopt the AI solutions, right? And I think the most important assumptions that we need to address is the last point. AI is only for larger and tech-savvy organizations. So a lot of times when you speak to the management of companies, right, especially for SMEs, they believe that AI is only applicable to the big boys, right, like the Google, Facebook, Twitter of the world. And being a smaller companies or being in an industry that is more traditional, it's very hard for them to adopt AI, right? And this is what we hope to address as well through this AI Readiness Index. Okay, and we also have a lot of questions that we see that keep coming to us, right? So when we talk to our companies, and let's say at the end of the meeting or the discussion, when we tell the company that your organization is not ready for AI yet, then of course the question they'll ask is, okay, so how do I know whether I'm ready for AI? Or what can I do to become more ready for AI? And how do I ensure that we have the right use cases to pursue for AI? So these are the common questions that we face across different sectors, across different company sizes as well. Right? So through this AI Readiness Index, we hope that we can give a way for companies to get these questions resolved. Okay. So I'll be introducing to you AIRI. So AIRI is an index that we have designed. It's designed to be an actionable framework for organizations. Right? So this AIRI, the objective is to allow organizations to understand where they are in terms of their organization AI readiness. Once they are able to do that, then they will be able to identify the gaps between the current AI readiness and where they desire to be at based on their business strategies. Right? So this is very important to highlight because not everybody needs to hire a data scientist team to implement AI in the organizations. For some companies, they're happy to be where they are. Let's say, for example, to buy off commercially off-the-shelf solutions for their organizations to adopt AI. So not everybody needs to reach that stage where they need to hire AI engineers. Right? I will go through more in depth later on. Okay, and lastly, with the first 2 points covered, it will help the companies to implement programs to improve their AI readiness. Okay, so how we come up with this AI Readiness Index is really through our experience in engaging more than 500 companies through our various programs. And we also look at some of the existing models and industry reports that is available in the industry. So what we have come with is these 4 main pillars that we believe any company needs to look at when they want to adopt AI solutions. We are talking about the organization readiness, business value readiness, data readiness, and the infrastructure readiness. So let me go through in details what are all these things that we are covering. So under organization readiness, there are 4 main things we're looking at. Okay? AI literacy, talent, governance, and management support. And under the business value readiness, we're looking at whether the company has identified any business use case internally to apply the AI on. Right? Because AI is just a tool, it's just a technology. Without the right use cases, it's very hard to see how it can be applied in their organizations. Under data, we're looking at reference data and data quality. And under the infra side, we're looking at ML and data infrastructure. So let me go into details what do each of these pillars mean. Okay, so under the 4 main pillars, right? These are the 4 things we look at. The organization readiness, we are looking at whether the organization has the foundations to embark on AI initiative, right? Because without, for instance, a good management support, most likely than not, the AI initiative within the organization will fail because AI will require changes in the business processes more often than not. And without backing from the senior management, it will be very hard to get departments from different organizations to come together to embark on that AI initiative. For business value readiness, we're looking at whether there's any use cases identified in the organizations and the potential value it brings, because otherwise the management might not see it as a priority to put resources to pursue certain areas of the businesses and apply AI to it. For data readiness, we're looking at whether the organization has reliable quality data in it, because AI is trained on data. Without data being collected by the organizations, it will be very hard for the AI engineers to do anything with the company. And lastly, for the infrastructure readiness, we are looking at whether the company has the right infrastructure. So we are looking at machine learning infrastructure because we simply cannot deploy an AI model on your laptop, even if you're using a latest laptop, because the computing resources required by AI is far more intense than what your laptop can potentially handle. So you're looking at whether the organization has sufficient IT servers, for example, or is using cloud computing to support the organization in rolling out the AI solutions. So that's the 4 pillars. So let me go into the dimensions, right, to illustrate how each of them can contribute to your organization. Under AI literacy, we are looking at whether your employees are AI literate. By AI literate, we are meaning we are looking at how well the employees can identify potential AI use cases and be savvy consumers of AI solutions. Right? Because for an organization to come with AI use cases, most of the time, the solutions, the use cases has to be from ground up, coming from the people who are on the ground most of the time. So they'll be the one who will be able to give good suggestions on the use cases to pursue. So an organization without good AI literacy will find it very hard to identify good use cases to pursue. For AI talent, we're looking at whether they have in-house AI engineers or data scientists to develop, integrate, and maintain AI models. For governance, what we're looking at is whether there is a policies in place to ensure that the AI is applied in the right manner, because if AI is applied in the wrong context, it might result in consequences that the company might not want to go into. Like say, for example, if the AI is biased and is making decisions that is harmful to users, then this is one area they want to avoid. Okay? For management support, we're looking at whether the organization has allocated resources for AI initiative. Business use case, as I mentioned earlier, is about whether the organization has identified suitable AI use cases and access the value propositions. So this will give an organizations a list of use cases and a potential ROI, right? And this will allow them to prioritize which are the use cases they want to pursue. For data, we're looking at the quality and whether there's a single source of truth. And lastly, for the infrastructure, we're looking at two things. The ML infrastructure. So this is more on the IT infrastructure. And on the data infrastructure, we're looking at whether the organization is storing data in the right way. Let's say, for example, are they still using Microsoft Excel to store the data, or they have migrated to something what we call a centralized web pool, such as a data warehouse or data lake, where all the data are accessible to the employees, so that it will be easier for them to train an AI model. Okay, so with that, what we have come up with is these categories here. So depending on where the company is, based on the 9 questions, right, we'll group the companies into either one of these 4 categories, from AI unaware all the way to AI competent. Okay, so for AI unaware and aware, what we recommend them to do is that they can still adopt AI solutions, but instead of developing AI solutions, what they can do is to adopt AI solution instead, right? Because for these 2 groups of companies, they will lack the internal resources to actively develop their customized AI solutions. So they'll be better off buying a solution or subscribe to SaaS solutions offered by the cloud vendors for the business needs. For organizations on the right-hand side, AI ready and AI competent. So this is where they can start to integrate customized models into their organizations. Right? So AI ready, they can have the ability to make pre-trained AI models through API call to integrate AI features into their products. And at the right-hand side will be AI competent. So this is where you will see that these organizations will have the internal capabilities to develop AI models in-house. So one thing I want to highlight is this: the size of enterprise does not dictate AI readiness. It can be a company can be a huge company in the logistic industry, but without the right readiness in place, more often than not, they won't be able to pursue customized AI use cases, right? And not every enterprise needs to reach the AI competent level. For some organizations, they are comfortable enough to be at AI aware level, right? And they can do whatever they need to get to that stage. Okay? So this is an example of an AI aware engagement that we have done. So by doing the AV assessment, you will have the chart on the left-hand side. So the current state. So based on the questions they answer, this will give them the organizational capability profile. So based on the question they answer, maybe they score 1 at AI talent, 1 at AI literacy, for example. And based on their desired state, which is based on their business objective, perhaps the management thinks that they need to be at AI governance level 3, because for these specific companies, they are in the healthcare industry, for instance. So they need to be at level 3 for AI governance, because if AI is applied wrongly in the healthcare sectors, the consequences could be disastrous for patients, right? So through this mapping of the dimensions, it will give a clear indication of where the gap is. And with this, the company can engage the right training providers, be it AS Singapore or any other training providers out there in the industry, to close up the gap identified in each of these areas. So this will help the management to bridge the gap, to ensure that whatever they have in-house is enough to support whatever they want to do in terms of AI. Okay, and at AS Singapore, what we have done is that we have mapped a few of our programs to each of these categories based on our AI Readiness Index. So let's say, for example, for AI unaware, the main focus for us is to increase the AI literacy of the organizations. Right? So they can do this through the AI for everybody. So this is a free 3 hours online course that anybody can go through online on demand to increase the AI literacy of the employees. Okay, so the mapping of this will help the organizations to understand what kind of programs are suitable for them. Okay, so before I end off my talk, I think I just want to emphasize that for any organization who is at the AI unaware stage, I will strongly recommend them to do something about it and try to be at least AI aware stage. Because it is only at AI aware, you'll be able to identify what are the potential use cases that you could apply in your organizations, and what are the things that you can do to improve or implement within your organizations, because otherwise the organization might be missing out a big piece of the data transformation era that we are entering into. So with that, thank you for your time.
Thank you, Tempo. Thank you very much for bringing the whole misnomer and concept of AI down to earth, and something which is very easy for us to associate with. I hope this session allows the audience to better understand the expectation of this AI journey. Clearly, it is not just deploying an app within an organization, but it involves the organization culture. It involves the 4 pillars of readiness that you suggest, right? And for the audience attention, APARA has recently set up an AI project panel to help organizations who want to understand their readiness. We'll work with you and try to put together some of these aspects of what can possibly be done. Now, what's important is this, right? We will also handhold you to look at the right problem definition and what is the expected solution to apply AI. Now, what's probably more important also is the fact that you need to be ready, and how can you get ready from unaware to competent. Well, once again, thank you, Mr. Lin Tempo from AI Singapore. This is really a very informative discussion. Although it's just a short presentation here, but I'd like to assure you that if any of the audience require any information, please feel free to contact us at apara.asia. Check out our website to find out more information. And in fact, on the 26th of August, we will be working together. We will be co-hosting another event with AI Singapore and the AI Professionals Association to talk more about the AI readiness, as well as case studies of organizations who have gone through this journey. So AI, so much for that. Let's now shift a little bit into the area of robotics. Well, AI can be applied to any organizations, right? Preferably of a certain size who is competent enough or aware enough to move forward. And AI can work in the construction industry. So while all of you look at what is possible, do think about how that can be considered within your organization. Shifting gear to robotics. Now, many of us think about robotics as the mechanical arm that picks up and drops off items from one place to another. But realistically, the robot can do a lot more than that. Today, we'd like to share with you a new technology that's becoming very, very active. Over the last 6 to 12 months, both in Europe and the US, 3D printed buildings are becoming a catch-on in many, many places, right? So I'd like to share with you a video that was played by CNBC in March this year. So can we have the video, please?
It may look like toothpaste, but this 3D printing technology is spitting out a 1,900 square foot house. The concrete foundation, interior and exterior walls, and utility conduits. This is the final product.
We're trying to build houses in half the time for half the price.
New York-based SQ4D printed the model home in about 2 days with barely 3 workers, and it's cheap.
Our profits will be higher, and we will be able to show that with more projects that we do.
How do you sell a 3D printed house?
I'd like to think it sells itself.
What is the weirdest thing anybody has ever said to you when they walk into this place?
Oh man, is it plastic?
The company now has the permits to build on this site down the road, the first 3D printed home for sale to the public. 1,500 square feet, 3 bedrooms, 2 baths, listed at just under $300,000. That's about half the price of a comparable new home in the area.
The offers are in the thousands. We are getting, people are seeing the price across the nation and loving that.
It's out layer by layer by layer, 2 inches thick.
Potential buyers like the Johnsons from Kansas City are already lining up.
We've been looking since September of last year, and a lot of the homes in the 2 counties are just impossible to find anything at this price.
And this quality.
So this is the result, the raw result of 3D printing. It's kind of like concrete corduroy, but if you don't love this look, they can smooth it out for you and make it look just like a regular wall. But for the home builders, this is a real game changer. Right now, they're up against a severe labor shortage as well as skyrocketing prices for lumber, and both of those are combining to just make their costs really, really difficult right now. So this could address both of those. Back to you guys.
Yeah, Diana, that's amazing. And the argument now largely seems to be price for 3D printing and what it can do in real estate. But 3D printing technology should allow companies to create shapes, perhaps do things with engineering that are impossible under traditional methods. Do you think that there's a premium end of this 3D printing and construction market?
Absolutely. In fact, we were talking to the builder about what the outside of the house could look like, and he was saying that you could put literally any image into the 3D printer and customize the outside of the home so it would look like shingles or it would look like a different type of wood. You could even put your face on the front of the home if you wanted to. So the possibilities are really endless with the technology. It's just going to be a question of what the buyers want and if the builders really, really buy into it.
Not my face. No, thank you. But point taken. Diana Olick, thank you.
Shepard Smith here. Thanks for watching CNBC on YouTube.
Well, there you go, guys. I believe the technology is here, right? We see those houses being built in the West, Europe, and in the US. We want to bring this technology here into Asia, particularly Southeast Asia. Now, what we have next are 2 speakers who are here in this part of the world, a speaker who resides in Singapore and a speaker from our neighboring country, Malaysia. They have the technology to help do 3D printed houses, low-rise structures, and more importantly, how it integrates with the BIM to enable, right, the smooth construction of such buildings. So let me relate to the 2 speakers. First, we have Mr. Jordy+Bos. Right, Mr. Jordy+Bos is with Witteveen+Bos, and he has been in this business for a long time. When I look at his resume, I was quite impressed with how many things that he has done. More importantly, right, he is the team leader for digital construction. Right, that's a new and interesting appointment, digital construction. So without much to do, right, Jordy, why don't I pass it over to you to present your case?
So in this session, I'm actually going to talk about how we are changing fundamentally the way we design, engineer, and build our cities, which includes 3D concrete printing. And I will get to that by the end of the presentation, so please hold on. Yeah, so as introduced, I'm working for Witteveen+Bos. We are a consultancy and engineering firm. We work on all kinds of projects related to infrastructure, building, water, and environment, almost 4,000 projects per year. And my team is focusing on specifically digital construction, which is all about automation and digitalization of the construction industry. We're active in 11 countries, headquarters is in the Netherlands, and I'm based in the office in Singapore. So yeah, let's start with this. As civil engineers, we're responsible for big accomplishments in the construction industry. Think about almost 1 kilometer high buildings in dense city areas, mega dams that produce sustainable energy, massive bridges and tunnels that connect people throughout the world, and dikes that protect countries against flooding. But the industry is also, as you probably know, facing some challenges. It's responsible for almost 39% of the worldwide CO2 emissions, which also includes, of course, the operational phase of the buildings. And the productivity is quite a bit lower compared to other industries, almost 30%. And there are more issues, as you are most likely aware of. But as one of the biggest industries worldwide, almost 13% of the world's GDP, making an impact on our industry will make a very big positive impact worldwide. So that's a big opportunity. And therefore, I think we should change the way we design, engineer, and build our cities. So let's have a quick look at how construction industry is typically organized. It's very project-based organized, right? Every project, we start from scratch. We develop a project with a certain, economic idea behind it. We start to design it, engineer it, all completely from scratch. Set up the whole project organization with all kinds of parties involved, often temporary subcontractors, temporary staff even, temporary equipment, rented. And with all of this together, we start to, construct this building bit by bit in a manual way. Well, all of this together leads to a very fragmented industry, a lot of manual work involved, a lot of parties involved, very hard to coordinate, almost no repetition in standardization, and therefore very hard to industrialize. Complex contracts because of so many parties are involved, a lot of risks, and the risks are often moved down in the value chain instead of actually being properly addressed. And yeah, this leads to the fact that there's almost no economies of scale opportunities, no industrialization, and risks for time and budget overruns. Almost no budget left for R&D. But there are quite some catalysts and emerging trends right now that will change this in the coming years. As was mentioned in the video just now, a shortage of skilled labor in the construction industry, increased need for affordable infrastructure and housing, as was also mentioned in the video, but also stricter regulations for sustainability, safety, repeatability, increasing requirements from customers and owners. But on top of that, we have also the emerging trends like 3D construction printing and other industrialization, like automated precast lines. Digitalization is getting there. BIM is almost a standard in any project. New and sustainable materials and new entrants are entering the market. And I think the presentation from Bina after my presentation is a great example of a typical new entrant for the construction industry with a new approach and vision on the construction industry. So based on this, the expectation is that the industry will change. And this is not invented by myself. This is coming from McKinsey. And they think that the construction industry will go from a project-based approach to a product-based approach. So we work more with standardized products, and buildings are designed with those standardized products. And those products are manufactured in places who are specialized in producing that part and can deliver a consistent high quality at a consistent price. And the construction process becomes more assembly of all those building components. The value chain will become less complex, less parties involved, companies will become specialized, and certain larger players will control or at least overview a large part of this whole value chain through digitalization. And AI is an important part of this, for example, to predict what is going on in the processes. And yeah, therefore I would like to show you a few, let's say, seamless digital tools and processes that we are working on that fit perfectly to this. And I will end with 3D concrete printing as one of the tools. So one of the things that we're working on is, for example, parametric design. parametric design, we can create an endless amount of variations of what I call a design family. So it's a similar looking design, but you can change the design by just updating the parameters, from the length, the width, the height, even the shape. And we can generate all these designs with just a mouse click, because it's what we call a computational design. It's basically set up with a sort of software script that generates the design based on our input. So it takes a bit of time to set it up, but once it is set up, you can generate all these designs. And this is also product-based, right? Because there's a lot of repetition in the type of building components in these designs. So that helps a lot to work towards it. Moving on to the engineering stage, there are a lot of disciplines involved in the engineering of a building. Structural engineering, acoustics, mechanical engineering, and so on. And they all need to exchange a lot of information with each other. And because every project is so new, they need to start from scratch every time again. Therefore, we are developing a platform called ONT to connect all these different applications with each other, and also take data from databases as starting points for those calculations. So with a product-based approach, we can use all those properties from those known products and use that in the structural calculations, for example, without figuring out every time again what the properties are of this wall and which concrete we need to use and this and this and this, all standardized, speeding up engineering processes a lot and avoid making, for example, mistakes in those processes. We also present these complex calculations in a more user-friendly way by going digital again. We present, for example, here, the fire safety engineering in virtual reality. So you see the simulation of smoke spread and the simulation of people evacuating in an underground station. And these are very complex calculations, but by presenting them in VR, any stakeholder can actually understand what the outcomes will be in a kind of emergency situation, how it will look like, and if that is the desired way of dealing with the emergency situation without the need to understand those complex calculations. And we do the same with, for example, infrastructure designs, where we have developed a driving simulator so you can drive over a highway in virtual reality. This is all based on the digital 3D models that we create. And the traffic that you see in this kind of serious game is coming from real validated traffic simulations, certified traffic simulations that are used to calculate if a junction is, for example, able to handle all the traffic. And this is live integrated in the serious game, so you can actually experience real traffic in the game and validate the design together with your stakeholders. So this all helps to get your stakeholders on board, make informed decisions, use your digital data, including AI, to make the right decisions. And also during the construction phase, we are developing an online platform that helps to manage all of this. We are doing this together with the Housing and Development Board. This is a typical single source of truth that was mentioned in the previous AI presentation, where we collect all information related to the design, the manufacturing, the assembly, contract issues, documents in a central place, manage it all from there, single source of truth, making the information available for everyone, anytime, from anywhere, in an online web-based platform. So this is completely developed in-house for H2B. And the beauty is that all information is connected to each other. So changing something here will also change something there. Or if next week the assembly of a certain amount of components is planned, but the manufacturing is behind the schedule, we can see that in the platform and we can adapt to that to avoid, for example, any delay. So yeah, this typically avoids budget overruns because we closely monitor everything, time overrun because we signal potential delays early, and we avoid rework and mistakes because everyone is making use of the most up-to-date information. So no outdated drawings anymore, and so on. And then moving over to construction, this is where 3D concrete printing comes in. This is technology that we are now working on for almost 6 years already. This started for us with a research project in the Netherlands at Eindhoven University with a whole group of partners. And yeah, meanwhile, we are working on this 6 years and we are working towards pilot projects to implement this technology with a large group of partners involved. So you're looking here, for example, on the right side at the 3D concrete printer that we have installed in Singapore at the Center of Building Research. And this is where we currently do our R&D with 3D concrete printing. So the advantage of 3D concrete printing is that it is fully automated. We don't need any formwork, so we save a lot of materials. Additional design freedom because we don't need those flat formwork panels anymore. Yeah, we save on manpower, save on material. We only use material we actually need it, and I will jump into this a little bit more. But also this you can see as a kind of product-based approach where components could be manufactured off-site, for example, for high-rise, modular, and stacked. And there's still a certain amount of design freedom when using 3D concrete printing because you don't need the formwork, but there is a certain standardization in the connections, dimensions, the waterproofing, all those kind of things that you can standardize. But without the formwork, we can still offer design freedom in a product-based approach. So let's have a closer look at construction 3D printing. How does it actually work? Well, construction 3D printing is completely centered about a robot. And this can be any robot actually, because the whole idea of this robot is that it's moving a printhead. So the robot can be a typical robotic arm that are used a lot in automotive manufacturing. Can be a gantry robot, and there are also quite some robotics developed specifically for construction 3D printing. But in the end, it's always moving the printhead. The printhead is extruding concrete, and this concrete is placed layer by layer to form the desired object. And the concrete is coming from a mixing pump that is mixing a dry material with water and pumping it to the printhead. All of this is controlled by a robot controller that includes the robot and the pump and the mixing process. And this robot controller is receiving instructions. The instructions are coming from a file that we generate based on our 3D model. So this is again the link between us as engineering firm and 3D concrete printing, which is more, basically for a contractor who's actually doing the execution. But we have the 3D models, and we can send those 3D models to a 3D printer. So there's a very short lead time from design to manufacturing, which brings up a lot of opportunities. If you control all of this in the correct way, you're able to 3D print concrete components layer by layer without any formwork, barely any labor involved, and no material waste, for example, because we only use concrete where we actually need it. So I really believe in this technology, not only because it's 3D printing, but because it's a great base for many other robotic technologies that can connect to this or work in the same way, provides a kind of platform to make all of this possible. Think about, for example, fabrication of rebar cages that in other research projects are being done with robotics already. This can be integrated in the same type of robotics, produced based on the same type of 3D models, managed with the same type of software. So that's the rebar, but also the surface finishing can be done already during printing with an additional robotic device. And after printing, you can think about, let's say, the so-called single task robotics. We can do the tiling or painting, like spray painting, all those kind of things. So that all can be done in the same kind of platform. And that is why I believe in this technology. So like I say, for construction 3D printing, we have a relatively product-based approach where we develop parametric objects that can be 3D printed directly without the need for any design and engineering. Just type in your parameters, like you want urban furniture. Here we have 3 examples: urban bench, a planter, which we call a green wall because you can place the plants in the wall, and a staircase. So whatever dimension you need for that, you type it in, the length, the width, the height, and it generates the design, and we can send it directly to the printer. And we have set up the model in such a way that whatever parameter you type in, it will be printable, right? It will have a certain limit for the length, the height, and the width to make sure it's printable. So this is where we save a lot of time on the design and the engineering. And we are working on a pilot project to apply all of this in a true construction project. So an example of that is Project Milestone, which is done by the group in the Netherlands. We're also working on this research project since the very beginning, and they are developing livable houses where people can actually live. That means they're permitted, follow standards, design codes, and so on. There's a lot of research work going on in the background that I don't have time to show today to make all of that possible. But for this project, we have now worked on the first house, which you see on the left side. It's a one-story house. And they're now working towards the houses on the right side, two-story houses. Also here, similar principle, parametric design as a starting point. We can generate a lot of different design variations, in this case based on the floor plan, the footprint, the contour of the building. So by changing the contour, let me show here, it generates a new house, and we can generate plenty of design variations in just a matter of minutes. And this already takes into account the printing capabilities of the printer that is supposed to print it, in terms of size, dimensions, connections, and so on. That design can be sent to the 3D concrete printer. Of course, there is still quite some verification in between. I'll get back to that to make sure the structure is safe. But the printer can directly operate from the 3D model, print the building components, and then we can transport it to the construction site. So the first house has been opened last month. The first residents are now living there. So that's a proof that it is a true livable house. If you look inside, it looks beautiful, just like in the video that you saw earlier. Also in this house, the printed layers are still present in certain areas of the house to show it is 3D printed, with a very consistent layer that actually is a nice architectural feature of the house. And to me, it looks definitely like a great house. I would love to live there. So let's talk about why would we do all this? Why would we 3D print a house? Well, of course, the tailor-made houses that are generated with the parametric designs allow us to create a house exactly in the way you want it. Make sure that there's a lot of design freedom. Cities don't look boring. You know, you can create neighborhoods where every house looks a little bit different, gets its own character. These houses can be printed on demand by the 3D printers based on digital designs. Short lead time, can be done faster, less labor, way less complex supply chain. You can see as consultant engineers, we're sending it to the printer. So the whole process becomes just simplified. Way less chance for errors and mistakes, for example. And we can make use effectively of materials, no production waste. And the examples on the bottom left and the center are very interesting. These are not printed by us, but these are great examples of that you can design your structure in such a way that you only use material where you, for example, structurally actually need it. So you can follow the stress pattern in the floor, so you're in the floor slab, to only apply material where you actually need it. And yeah, then we have the whole platform for many other robotic technologies to automate this product-based industry. Yeah, the technology is still in a relatively early stage, I would say. That means there is no design code or standard yet that tells you how you should calculate or design such, structural component or complete house. Therefore, we make use of the Eurocode, design assisted by testing. There's a whole testing program to validate that whatever we calculate is correct and works the same in practice. We do material tests to find out the material properties. We use that to do calculations. We produce a scale model and do destructive testing to test if our calculations were correct. Then we print the final model, test it one more time to check if it can handle the design load, for example. And by using a product-based approach, we can reuse all of this, right, in the next bridge. So we're working on a bigger bridge right now. It's longer, but the span is similar. So it has similar bridge components, slightly different shape, but similar principles. And in this way, we can evolve the bridge and also reuse a lot of information and data. And this next bridge is now being assembled at the moment, actually. Yeah, so 3D concrete printing is no longer something that just happens in a lab, like how it started for us 6 years ago. All around the world, you can find pilot projects in Asia, in Europe, in America, South America. So yeah, it's really entering a high technology readiness level. And also a lot of different applications are being, let's say, experimented with. From affordable housing to premium housing, printing those houses completely on-site or off-site, up to printing just building components, complex shaped columns, or repeating building components like cladding. So there's a lot of possibilities and a lot of opportunities to explore. And you see that the 3D printers also start to shape towards a specific application. Like affordable housing printed on site will have a typical printer that is focused on that. With a high quality component with a very complex shape, we'll have a different type of printer, different type of printhead for usage offsite. So we are now opening up what we call a Center of Excellence in Singapore. The goal is to make 3D concrete printing available for everyone who want to experiment with 3D concrete printing, learn more about it, or even do a pilot project. And we have a whole range of services from consultancy to design, engineering, and actual 3D concrete printing services to make it possible. The center will be opened up soon. So if you would like to stay informed, connect to me on LinkedIn, for example. And I would like to close off with this last note. I really think the change towards a product base is something to expect. Disruption is, as you can see, on the horizon. This is not something that I have invented. You know, McKinsey and so on are basing this on a lot of research that has been done over the past months and years. And strategic changes are likely to be needed to remain competitive in this changing environment. And I actually think that this change has started already. So I would say let's embrace this as a big opportunity to make the world by construction an even better place. Thanks a lot for your time. And if you have any questions, feel free to drop them in the chat.
Thank you, Jordy. This is a really exciting what you've shared for the audience and what's to come. I like the part you mentioned about shifting from project-based to product-based. And in fact, there's definitely opportunities for 3D printing to start with product printing back in the factories and then shipping it to site to do prefab building. So that the combination of the existing prefab technology as well as 3D printing for the products of the building are definitely very, very viable, particularly for the high-rise buildings. Now, I want to quickly move on to our next speaker. We have the privilege of somebody who has actually imported this machine into the region here, and particularly will be the first 3D printing company in Malaysia. Let us welcome Mr. Azman, who is the CEO and co-founder of Bina Consultancy Group, and let him share with you what he can bring to the audience. Azman, over to you, please.
Thank you, Oliver. The warm welcome. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon to everybody. I'm Azman Azeez, the co-founder and CEO of Bina from Malaysia. And we are currently the proud sole distributor for cobalt in Malaysia and Singapore. We are a young and vibrant company that believes in new technologies and innovation that will further drive the local industries and the country's economy as a whole. And we believe that in today's digital era, adapting and adopting new technologies around the world is significant to achieve a sustainable environment for the economy and well-being of a country. For a start, we are highly invested in the latest 3D construction technology, or we call it 3Dcp technology, that would benefit the construction industry and millions of first-time homeowners that in line with our mission and vision, which is to provide affordable homes for the B40 groups especially. Now, affordable housing is becoming to be a prevalent issue among Malaysians, especially concerning the B40 and the FTHO, as you call it, the first-time homeowners groups. Now, based on the research, there are about 1 million projected shortage in affordable housing in Malaysia alone. So we believe that with cobalt's technology, and it is considered the state-of-the-art and the cutting-edge leading solution in the construction industry, especially related to the affordable housing. Now, globally, there's a few companies producing or manufacturing the 3DCP technology, but we chose cobalt. You may ask why? So simply because they are the pioneer in this technology. They printed the first building in Europe. They developed Bot 2, which is the latest version of their printer, which is the fastest construction printer in the market. And they have many experience in the large-scale 3D printing development. Now, besides that, they have many success stories around the globe and secured many international partners, such as GE, Lafarge Holcim, and recently, a few days ago, JCG Japan is also on board with them, utilizing their printer. In India, they have L&T, and in Dubai, they have MR Group and many other stakeholders. In fact, AIRI Group is a shareholder in their company. On top of that, Cobalt, alongside with its partner across the globe, including Bina, has a comprehensive plan, not just to tackle the issue that we have at hand, which I mentioned regarding the affordable housing, but also to boost and transform the construction industry in Malaysia and Singapore and moving towards Southeast Asia region. Now, we aspire to be the 3DCP's technology enabler in Malaysia and further establish this technology in Malaysia and Singapore for a start. Now, for the record, we have ordered 2 sets of printer, and coincidentally, today, we will receive the first printer that will be arriving in our port. And we are very excited about this, and we hope to get the printer running and to showcase the capabilities of 3DCP technology very soon in Malaysia. And we will continuously work with government agency, of course, the regulatory bodies, learning institution, to further enhance the application of this technology in Malaysia. Now, for our current progress, just for your information, Bina is currently working with Malaysian Construction Industry Development Board, CIDB. It's quite similar with HDB in the context of Singapore, to print the first 3D printed home in this region. We will test our newly arrived printer to print complex structures and designs to overcome the limitation that conventional construction faces. Now, for your information, based on our projection, to print the walls of the house takes only less than 48 hours. And based on our cost projection, we could achieve up to 30 to 40% cost savings compared to the conventional or traditional construction method for our first 3D printed home. However, bear in mind that this is the first time we have our hands on the printer, and we do expect some setbacks. But as we utilize and operate more and more, we believe that we'll be more efficient and competent in the near future. So now let's go to the interesting part, the benefits of 3DCP. I'm sure Jordy has mentioned some of it. And as I mentioned earlier, speed is definitely a key benefit where we could achieve higher productivity in our development that leads to, of course, cost savings. And as for labor requirement, for Cobalt's technology, we only require 2 people to operate the printer, thus reducing the dependency on foreign labor, which is really a plus point, especially during this pandemic. Automation in the construction process, dwelling ourselves, adopting the IARA 4.0, moving towards digitalization of the construction industry. Now, with high technology application, we are able to improve and upgrade local contractors' skill set to move away from the normal construction problems, especially related to the 3D acronyms, dangerous, dirty, and difficult jobs. Flexibility of designs, we're no longer bounded with conventional constraints. With software and machine involvement, we can effectively reduce errors in the development process, thus reduce wastage. Mobility advantage, the machine, our gantry system can be assembled and disassembled for easy transportation, and it takes less than 4 hours installation time. And of course, moving forward, the application of this 3DCP technology is not just on the wall and foundation, but moving forward, Cobalt International partners is inventing new upgrades on their printers so that they be able to print more components of the construction process. Now, as you can see right here, based on this UK study, the development cost was able to be reduced by 33% using 3DCP technology. And there is a significant saving time taken with over 37% of time reduction. Now, with that being said, I'm sure all of you are wondering, how does the 3DCP really works? Let's go to a little bit of the technical part. Now, as you can see here, Cobalt's printer, it's a modular design, and we utilize the gantry type system. You can decide the size of the printers by its modules, where you can add modules to fit your project specification. Now, the whole journey begins from your device, whether it's your laptop or iPads, where you will create your 3D format design, whether through Rivet, AutoCAD, Beam, or any other 3D softwares. And you will then fit it into Cobalt's proprietary software, where we call it as Cobalt Slicer. The software then instructs the printer on how to print, and you can also make configuration in the software itself, where you have the freedom to determine the speed of the printer, the movement, and the method of printing. Now, the printer would then give order to the batch plant to mix according to the requirement of concrete material you desire. The material would then be processed, transferred to the pump, and push the concrete material to the printer, and your building or structure will be printed. Now, all of these are done automatically. In fact, you will only need 2 people, as I mentioned earlier, just 2 people to operate the printer. So with cobot technology, you can control the printer using your laptop, PC, iPad, or even smartphone. For cobot's printer, as you can see right here, this is the normal layout. So you can see the batching plant is right there, the pump, and the printer is on the right side with the printing area. Now, the second question that comes probably from your side is that what kind of material can be used? Now, with cobot technology, the material recipe is open source, which means the user will determine the material recipe themselves, giving the flexibility of concrete material that can be used in your development. Now, more questions must be in your head. How does the plumbing works, insulation, electrical conduit is installed? With all these questions in mind, ladies and gentlemen, what we would like to emphasize here is that just like the concrete material and the design, the end user will determine how it's going to be done. It is a very flexible process with 3DCP technology, especially from cobot's technology. And it's very important to note that the printer is just a tool. You as the end user on the other side can decide how to utilize the tool, giving more control and flexibility in your development process. So KA Bina is currently engaging and in talks with small to large developers in Malaysia and Singapore, and we are proud that we have garnered so much interest in this region. We are hopeful that more parties and companies will partake in the adoption of this new technology, as we believe in the advent of the IARA 4.0 that 3DCP is the way forward to transform the construction industry as a whole. As you can see here, there's a growing demand in the additive manufacturing and 3D printing technology in ASEAN region alone. For ASEAN region, it is led by Singapore, Thailand, and yours truly, Malaysia. KA Bina is riding on the growing interests, and as a partner of Cobot International, we aim to be the catalyst for the adoption of 3DCP in this region. We have also identified several frontiers to boost the adoption of 3DCP in this region. And some of these frontiers covers the R&D process to improve the technology further, to develop the right concrete material, which should be locally sourced. That's very important. We have to focus on developing the 3D printers itself so that it could fit with local needs. We have to provide the right material and modules for training and capacity building purposes moving forward. And last but not least, we shall connect local companies with regional players because we feel that such global engagement can allow for more creative and innovative solutions to be developed. Finally, on behalf of KA Bina, alongside our trusted principal partner, Cobot International, we call upon all industry players to join us and be part of this journey to make construction great again. Thank you very much. And if we have time, we'd like to show a video, if that's possible. Thank you.